I turned 18 the day we moved into College Dorm. Dorm moving day was on my birthday. All right, let's do this. We are doing things. I know, I'm horrifyingly cruel.
Actually, you're pretty nice.
But the seniors aren't.
Yeah, what about seniors?
Too bad for them. It is not a school-sanctioned activity.
For real?
For real.
Yeah, no, seniors can do
No, it is an unexcused. Like, it's just one of those things, they're willing to take it.
Is this anything else?
Huh? We'll touch on a little bit that's new, but it's based off of things we've done.
It's just like a cultural thing.
Really? I didn't know that.
What?
I thought it was undefeated.
No, it's
Oh,
not.
I heard that.
Oh no, Skip Day is not a school sanctioned event. It is just like a collective protest. Like everybody decides the same. It's like a protest day. So. But no, it's not a school sanctioned event.
Can we do like the juniors thing?
I mean, technically there's nothing to stop you. But you'd have to be organized for it, and the school isn't going to organize it for you. And they might get grumpy if everyone starts doing it. They kind of just like,
We do it for a whole week.
Whoa.
I'm pretty sure that, I would say,
We
then
do it for a final.
we're gonna wind up with problems with other kinds of paperwork stuff. I'm just saying, just because you're gone doesn't excuse you from things you don't do. So that just means we get zeros on those. I don't recommend skipping finals.
I would not recommend it either.
What if we skip when there's AP exams and nobody appears to AP exams?
Then that's your AP exam down the drain.
As I say, then if you wanted to take the AP exam, you'd have to pay for it yourself.
Oh, yeah.
Because the school covers the cost of that if you do it with the school. Because the suckers are like, I want to say they're like $200 to take it. If you take, as I say, it's somewhere like 100 to 200. It's like SAT prices if you want to take it, and the school's not supporting it for it. It's one of those, again, like we're approaching adulthood and we can make adult choices, but we also then sometimes get the adult consequences for the choices that we make.
I don't like it. I'm willing to.
Yeah, no, valid. You don't have to like it, but it does happen. Okay. Let's lock back in. So we've got a sequence up here. This is very much like what we were doing on Friday. We're going to see if we can find the 5th term of the sequence, the 10th term of the sequence, and then see if we can write a rule for the nth term. So, what's up? Hang on a second. The 24th, we will have our. I know. So then let's look at this stuff. So here's our formulas if we still need them. Here's our common difference formula. So first thing we need to figure out is our common difference. We've got our first term, our a sub 1, which is 1. Our second term, our a sub 2, which is 3. Our third term, a sub 3, which is that 5. Our fourth term, a sub 4, which is that 7. How are these changing? They're adding 2. So our common difference is 2. It's how it's changing between them. We're adding 2. So we're asked to find the 5th term. We could find it manually this way. What would a sub 5 be? 9. It's the very next one. So we know that it's 1 plus 2 gives us 3, plus 2 gives us 5, plus 2 gives us 7, plus 2 gives us 9. I got the 5th term right here. I don't really want to have to figure out all the ones in between, so we're going to find the 10th one using the formula, the recursive formula. What's up? Yes, I was just trying to find out my page. I couldn't find it. So if we're wanting to find our a sub 10, using the formulas that we did last week, that's when we have our a sub n with our 1 or with our, yeah, a sub 1 plus our n minus 1 times the common difference. That guy. So a sub 1 we know, that's this guy up here. So we can do our 1 plus n minus 1 times our common difference, 2. Oh, except we weren't just looking for kind of our generic n, we were looking for 10, a sub 10 here. So we're just looking to get a value here. We're not necessarily looking for the equation on this guy. We just want the value. So we have our 1 plus 10 minus 1, which is 9 times 2.
Are you sure it's 19?
Sorry.
Isn't it 17?
It's 19.
19. Okay, so then let's see if we can find our a sub n. So if we do the same thing, but instead of plugging in our 10, we leave it as the n bit. So for keeping the a sub n, we can still substitute in our 1. Let's simplify that because that's a little bit of a mess. Because we're multiplying out that 2. So then when we combine our like terms together, Oop. Nope, just leave it. We're not solving for n. We're just getting it into b, combining like terms. 2n minus 1. That's it. Because then if I wanted to find a sub 30, I could plug and chug. If I want to find a sub 100, plug and chug.
Oh, to the end? Wait. Is that like a shorter way to do the other one up here?
Yes, you could absolutely find this first and use it to find these guys. Totally fine. I have an answer.
You know, like, for the second equation, how do you know, like, which, what to put for, like, the a sub 1? You just put it in. Oh, wait, never.
You're not. Sometimes it takes talking it through to get an answer to your own question, and you found your own answer there, so you're good. You answered your own question. That is quite the opposite of. We don't have to. We could use any, in the formula, we often had this as a sub k, and it would be n minus k. If we don't have a sub 1, we can use whichever one we have here as long as we have a term. So most of the time we are going to be given numbers, but not every time. Sometimes we're going to have some like weird polynomial looking stuff. So I'm going to show you a weird looking polynomial one. So here's a new sequence. We've got, to be fair, they lines. We've got, I know there's some algebra in your pre-cal, ew. We've got our first term, which is minus 8x plus 12. Our second term, which is minus 6x plus 9. Our third term, which is minus 4x plus 6. And our fourth term, which is minus 2x plus 3.
That's 0 to 0. You gotta add, we should go like a positive 8x plus 12, actually. Yeah.
What are you trying to do? What do we need to find first? The common difference. So we're looking at how things have changed between these two pieces. I want to know the difference between this guy and this guy. So one way to set that up, to find our common difference, set it up as subtraction. Take this guy, our minus 6x plus 9, and subtract that one, minus 8x plus 12. Subtract it.
That's gonna be plus 2.
Careful, careful, please, because you've dropped a thing. So minus 6x minus negative 8x.
X plus. No, minus 3.
Try again.
Okay.
Negative 6 plus 8.
It's plus 2.
2x.
You can do that.
9 minus 12.
Minus 3.
12.
What? 9 minus negative 3.
Thank you.
This math is very complicated.
Really?
It's like y'all just trying to do it all in your head. Write things down. When in doubt, distribute. And scooch around. Minus 6x plus 8x plus 9x. Or plus 9. Not x. Minus 12. Rearrange stuff. Put the x's next to each other. Write things down. You don't have to do it in your head. But our common difference here is 2x minus 3. That's how it's changing in between here. This is adding 2x minus 3. This is adding 2x minus 3. This is adding 2x minus 3. So let's find our next term in the piece. What's up?
0x. That's minus 0.
So the fact that he's jumping ahead of us. He's jumping ahead of us. So what we have here, this is our a sub 1. This one's our a sub 2. This guy's our a sub 3. And this guy's our a sub 4. So if we want to find our a sub 5, we can do it shortcut mode, where I take my a sub 4 and we add the common difference, get to the very next piece. So if I take my, what's up? Our minus 2x plus 3, and we add our common difference, which was our 2x minus 3. I was just explaining it. It's not that I didn't trust you. Goodness. Our a sub 5. I just can't say, yes, David's right, and then move on until no one else would have it. It's going to equal our minus 2x plus 2x. We get 0 x's. Our positive 3 minus 3, we get 0. So 0 x's plus 0. You can just put a 0.
Can we just multiply that by 5 to get to 10?
Let's see if that's true. If I could multiply that by 5 and have it get to 10. Because if I multiply the 0 by 5.
No, I mean 2.
Oh. Yes, that would do the exact same thing. Yes. As long as you did it in parentheses there. Yes. I was going to be like, what you doing? So let's see how we're going to get a sub 10. So we're going to actually write it out, because you're exactly right, but I'm still going to do the work. So our a sub 10, we're going to take our a sub 1 plus our n minus 1 times that common difference. We know all those pieces because my a sub 10 means I know my n. Our a sub 1, that's our minus 8x plus 12. Our n is that 10 minus 1. And our common difference is that 2x minus 3. And that looks like a mess. Because I took my n here. So let's simplify this, because that's gross. A sub 10. We have our minus 8x plus 12 plus 9 times 2x minus 3 plus 18x minus 27, because we took our 9 and then distributed it. A sub 10 is our 10x minus 15.
But this is a rare scenario, right, where it's like it's 0, so you can just multiply
So doing that, what you were saying right there where we're multiplying it and you're multiplying it by 5, right? 100% what you just did was you took our a sub 1, whoops, not that, laser pointer. You took this and you took our difference and you're just substituting in the difference here. So you're using the other formula that was the k and the k there instinctively. Instinctively you're doing that. That's what that is when we don't have a sub 1, we're doing exactly what that is. Okay, so you're doing exactly the right thing. You're just replacing this and this with the pieces from up here. You're just starting at 4 and finding the difference between our 10 and our 4. Okay, so let's see if we can find the nth. I'm gonna scooch this to the right just so we have a little bit more space. So same kind of vibe, but instead of substituting in 10 for n, we're gonna leave it. This is gonna look gross, just to warn you. A sub n, I'm gonna take my, you can do a sub 1, you can do a sub k, whatever you wanna do. I'm gonna use my a sub 1, but this time we're doing our n minus 1, and we're not going to replace it with a different number. But we still have our common difference of 2x minus 3. We're not substituting in the 10. It's 100% the exact same vibe as over here. We're gonna still try and simplify it. We're just gonna have less pleasantness because we're substituting in our a sub 1, which was our,
Isn't that what we usually
mm-hmm.
That's not gonna look right.
Oh, because it's gonna have negative. Oh.
It's gonna have 2 variables. Because we're not replacing the n, we're not replacing the x. I'm gonna change the view over here just so it's, yep, so we substitute what a sub 1 is. And now we're going to get rid of all the parentheses.
Okay, I see the problem now. That's gonna be
Plus n times 2x. So 2xn. And plus 3.
you get
And then we're gonna combine our like terms together. We do have a couple of like terms here.
negative 10x plus 15 plus 2x.
Negative.
Because we've got our minus 8x and our minus 2x. And then we're gonna have our 12 and our 3.
Negative.
So our a sub n formula here, we've got our minus 10x plus 15 plus 2xn minus 3n. Ew. Agreed. That's gross as they get. Like, I think that's about as gross as we're gonna see. So then if we wanted to find a sub 15, I could sub that in for n, and we would be able to get our exact right statement. If I wanted to find a sub 500, I could substitute that in for n, and we could find our statement much, much quicker than if I tried to go through one of the original equations. Yes, dear?
And you said we could find that first to make those.
If you want to start here, and that would replace this work to be just kind of a plug and chug from here, totally fine. But it's just one of those things, we tend to do it in this order, especially as we're teaching it, because this is a lot more plug and chuggy going through it beginning with, and this has a lot more thought to begin with, and then we're like, oh, well, if I did that, I saved myself work. But so yeah, once we get to that point, switch your order, totally fine with me. Okay, questions on this one? The next one's gonna look like a story problem. It's not, I promise. It's not, I promise. So what we have here is that the 4th term of an arithmetic sequence is 5, and that the 9th term is 20. We're asked to find the 1st and 6th terms, and then write a rule for the nth term. They just wrote it in words. So we've got that the 4th term of the sequence is 5, and the 9th term is 20.
Hold on, say it again, please.
The 4th term is 5, and the 9th term is 20.
So we
we want to find the first term and we want to find the sixth term.
5, 6, 7,
You ran out of.
9.
Oh,
It's 12.
Oh, no, it's water.
No, that was, I'm out of coffee, but I haven't filled the one yet. Because I forgot home to wash it. Because, yeah, I'm just gonna leave it here for the weekend. Get dusty. All right. So they don't give us the first term this time. We have to find it. What we know, I know the fourth term. Oh, hang on, let me change the view so you're not jumping out of me. So the fourth term is 5. So that tells me a sub 4 is 5. And we know the ninth term is 20, so that's a sub 9. That's 20, right? We, first things first, need to try and find the common difference. We need to figure out what that term D is. What we're going to use is that same kind of formula we've been working with, our a sub n. I'm going to use the a sub k formula because we don't know a sub 1. A sub k plus n minus k times that difference. So we're used to using this with the 1 here and the 1 here, but it doesn't have to be. We can switch it out for any term. So what are we going to use for our n?
Nothing. You can use 5.
I was going to say,
No, 4.
we could put the 4. We're going to wind up with a lot more negative-y stuff.
Alright, 9.
So let's put the 9. Let's use a sub 9 as our n. That puts this as a sub n and 9 as the n, right? So substituting these pieces in. I mean, it'll totally work to use the 4. You're just going to wind up with a lot more negatives. So we're going to have these pieces, and then this is our 9, which means what are we going to use for our a sub k? This guy is our a sub k, so we are going to put the 5 in there, but I guess we're using 5 as the k. So this is going to be the value of 5, and this is going to be our k of 4.
So can we use any different one?
Whichever ones we're given. We're taking our figure numbers are the guys in the parentheses. So these little guys underneath are these guys over in the parentheses. These two pieces.
So we put down 5 equals 20 plus.
It's like we should wind up with the same answer when we do it the other way. I've not actually done it. It's just like less pleasant. But this 20 went, I'm just trying to color code on my highlights so we can see where things came from. Oh, there we go. So this was that one. This was that one. K is that one. And then there we go. This was this guy, which was this guy, which was this guy. There we go. So I was just kind of trying to match those up so we could see where the pieces were coming from. So let's work this around until we can figure out what that term D is. So we've got 20 equals 5 plus 9 minus 4, 5 times D. How do we solve for D? Minus 5, so we get that 15 equals 5D. So what is our common difference on this one? 3.
What?
So with us knowing that common difference, we can go back and find term 1. We can find the very first term in this sequence. Using this same guy, I can substitute and put 1 as my n, or I can put 1 here and solve it the other way. Either way is fine. I'm going to take my a sub 1. I'm going to put it as my a sub n this time. It still works. We just have to be really careful if we put the smaller one as what it equals, because when we substitute in using our a sub k, I'm going to keep using our a sub 4 for that one on this guy, just so that we can use that same set of color coding. Plus our n, which is 1, minus our k, which is 4, times our common difference, which we just found was 3. What are we going to get for our value of a sub 1? Correct. I just was double checking. Yeah, it's going to be negative 4, because 5 plus negative 3 times 3, so negative 9. That's going to give us a negative 4. What are we going to get for our, the other one they asked us for, which was our 6th term? What's a sub 6? Mm-hmm.
So my question, if I just like subtracted 3 from like
Yeah. I mean, that's how the arithmetic sequences work, is that it's all about that constant adding. It's moving as a linear function, basically. So our a sub 6 is going to be 11. What is our nth term? What is our equation going to be? Oh, that's not what I meant. A sub n. How are we going to get our equation for this guy? When in doubt, start it as an equation. You can use the one that's using our a sub 4, just like we did here. You can go back and use a sub 1, because we have that here. Whatever we want to do. I'm just going to keep using the 4, because we've already used it a couple of times. So we've got our a sub 4 plus our n minus 4. Somebody watching a powwow video? That's what it sounded like. Sounded like a powwow. My mother-in-law goes to powwows all the time. So fix this. Let's make this less gross, because it's super parentheses-y right now. Our a sub n equation.
5 plus 3n minus 12.
Mm-hmm.
Which is 3n minus 7.
Minus 7. Okay, so being able to write these as an equation is going to be one of those things that we use as we're going forward and stuff. Because the next thing we're going to do, which I'm going to kind of intro, we'll do a little bit with, but I'm, not going to go super hard on it because, half the people ain't here. I think. Is the next one? Oh, no, the next one's another one like this. Let's do another one like this. There's a little decimally. So we're going to find our first term, and we're going to find our nth term. So we're not finding a random one in the middle this time. We're just finding first and nth.
D equals 2.5.
Yes. All right, start by finding our common difference. You're exactly right. Our common difference we're getting from our a sub 6 and our a sub 7. Since we have sequential terms, I can just straight up subtract my 5.2 minus the 2.7 to get our common difference. Since we have sequential terms, we can just subtract them. Otherwise, you got to plug them in the formula like we did in the last one.
2.5.
Yes. So our common difference is 2.5.
2.5. Understood.
So now we need to find our first term and our nth term. How are we going to start it when we're trying to find our a sub 1? we can write the whole equation. It's okay. You don't have to do it in your head. So if we want to use our a sub 6, we can totally do that where we take our 2.7 plus our n, which is 1, minus the one we're starting with, which is 6, and our common difference, which is 2.5.
Yep, if I'm not mistaken.
So go through it. Figure out what is the value of a sub 1.
16.7.
What I have.
Really?
-9.8.
That's what I have.
Wait a minute. I got 15.2. I love that. I love doing
Wow.
math. I love doing math, guys. Is that 2.5 times 5 and then plus 2.7?
1 minus 6.
5. Oh,
There
what
it
I have
is.
to do that?
Yeah, you actually have to do that. It's a negative 5.
Ah, that's worth
It makes a difference. Makes a difference. All right. Then we need our nth equation. So I've got my a sub 1. We can use that if you want to. You can still use our a sub 6. You can still use a sub 7. You can use whichever term we want. What's up?
I thought the M term was 2.5. That's my part.
We have our difference is 2.5.
Ah,
We found the first term
so why do we need the nth term here?
because we're asked to find the nth term. So a sub n
For -9.8, plus parentheses, n,
mm-hmm,
minus 2.
times 2.5. And then when we multiply that out and we simplify things together, yep. So our negative 9.8 minus 2.5 is going to give us what, fully simplified?
Negative 12.3.
12.3.
Do that, wait, no, do that in your head. 9.8. Negative 9.8.
Wait a minute.
I didn't see the L.
Oh, wait. Oh, minus 12.3. That makes sense.
Okay. Questions on these guys?
I have one question. Can we get a review for this quiz, please?
Yes, I will get the review for it.
Right now?
Finish the section. No, I don't have them printed yet, dude. I was gonna say, dude. Come on, dude. I'm gonna put up our next set of formulas we're gonna use in this section. Oh my gosh, why? Because we've done sequences and then sums, and we did arithmetic sequences. Now we're gonna sum some arithmetic sequences. So I'm gonna show you this. This is a formula you're gonna need to know.
This is not on the quiz, or is it on?
It could be.
Oh, it could be.
Honestly, I have not looked for it yet. It's been a minute. It's been like a year since I looked at that quiz. I genuinely don't remember.
No.
All right, this is going to be something we need to know. This is a symbol that says the sum of this sequence up to term n. So from 1 to whatever number, we can use this formula. So that's what this notation means, is we sum them up from, like if this was to 10, it would be 10.
Look at my boy.
And we take our first term and whatever that term is and we add them together times n over 2. This is plenty of information for you to memorize. If you want another one to memorize, this is the exact same thing, just having substituted in our formula that we've used for a sub n. That a sub 1 n minus 1 times that common difference. Yes, dear.
Are the brackets mean anything different than parentheses?
No, they're just big parentheses. So the way that the book gives you both of these formulas, but the way we get from this formula to here is we substitute this piece in, this formula we've been using in place of here, just so that we can have things not have two separate terms. So if we were to substitute that in so that we could look at stuff, our n over 2, we've got this bracket here. It's just a giant parentheses. My A is looking rather 9-ish, so I'm gonna write that A again. Plus, and if we substitute that in, our A sub 1, my turn, guys. Guys, my turn, thank you. So this is just taking that formula we had before and plugging it in here. Well, now I have A plus 1, or A sub 1, plus A sub 1, 2 A sub 1s, plus this thingy, that thingy. So it's the exact same formula. You don't have to memorize both. It is this guy plus this guy, smushed together. So we just take our first term and our last term and add them together, and we're gonna multiply it by n over 2. This is what we're gonna work with hardcore tomorrow. Okay, so we're gonna use this a bunch. And this is gonna straight up give us the sum. Like, it will give us the sum from k equals 1 to n of our a sub k. It's gonna be the same thing. It's giving us that same rule. Okay? So we're gonna work with that. We have 2 minutes left, so I'm not gonna give us a problem on it, but we'll work with those tomorrow. I mean, I could show you one if you really feel like it, but I was gonna put that up there for you. So.